Now, what if I said to you, you are not allowed to modify the cost on DSW2, but you must accomplish the goal of having 106 as the root port? Well, in that case, you have to go to the upstream neighbor. Because remember, it's the port ID here that is deciding what is happening right here, right now. Because cost is tied, bridge ID is tied, the port ID is the deciding factor. So in this case, you could modify the port ID within those BPDUs that are being sent to DSW2. So we go to DSW1. If I go to interface configuration mode for gigabit Ethernet 1/0/5, and I say spanning tree VLAN 10 port priority, I can change this value here. Well, not the whole thing. I can change this part of it. And we have to do it in increments of 16. 0 through 240. So if my goal is to have gigabit 1/0/6 on DSW2 as the root port, I have to give 105 in this case a higher priority than 106. So right now it's 128, so let's just give it 240 and see what happens. The output of do show span for VLAN 10 indicates that the new port ID is 240.5, which is significantly higher than 128.6. So therefore, DSW2 should have gigabit 1/0/6 as the root port, and it is. And 105 is the alternate port. So we were able to manipulate DSW2's decision without even changing DSW2. Let's go back to DSW1. Let's remove that command we typed in. And instead, let's now manipulate the priority of 106 instead on DSW1. So interface gigabit 1/0/6, spanning tree VLAN 10, port priority, and let's give it a value less than gigabit 1/0/5. So that way there, when DSW2 receives those port IDs, it's going to choose 106 as the superior port over 105. So let's just give it a value of 0 in this case. And if we go back over to DSW2, or let's verify our change on DSW1, do show spanning tree for VLAN 10. Now it's 0.6, which is definitely superior than 128.5. So DSW2 should successfully have 106 as the root, and it does. And it does. Notice the priority doesn't change on DSW2. It's still 128.6, 120.5. We are changing what is sent in the BPDUs from DSW1 to DSW2. That's what we have done here. So again, modifying DSW2's decision without changing anything on DSW2, we changed it on DSW1. So let's wrap this up by realizing that if you want to modify the path selection locally, you can use cost. If you want to influence a neighbor's path decision, you can use the port ID. However, that only works in one situation. Have you realized what type of situation that only works in? When you have parallel links between two devices and everything is equal. Cost is equal. Bridge IDs are equal. And therefore, the port ID has to break the tie. So the only way you could use the port ID to manipulate the neighbor is if you have a situation, as we are presenting you here, between DSW1 and DSW2. In a lot of cases, though, folks, in the real world, what are you going to do with those links? What are you going to create with them? An Ether channel bundle. So the majority of the time in the real world, you won't end up in this situation where you're manipulating port IDs or having devices make their decisions based on port ID, because you will have an Ether channel bundle set up to increase your throughput and for load balancing purposes.